Well, we're on our new unit, which is lesson 7, which is going to be focusing on factors and multiples and common denominators. So let's get started. This is lesson 7-1, which is understanding factors. So heading off to this very first one, our do you understand is this. It says, how are the lengths of the sides of the arrays shown on the grids on the previous page related to the factors of 12? Well, if you remember from our video, we had them arranging 12, and they had a block of 1 by 12, 12 by 1, 2 by 6s, 6 by 2s, 3 by 4s, and 4 by 6s. And it wants to know how are those related to our factors. So we're going to write it in a sentence, and let me get my pen cooperate. Oh, it's because I had my erasing on. So how are the lengths of the sides related of the arrays on the previous related to the factors? The lengths of the sides are its factors. So if you remember, we had a length of 1, a length of 12, a length of 3, a length of 4, and a length of 2, and a length of 6. Those are all of its factors. Now for question number 2, it says, what are the lengths of the sides of the arrays that show how 5 chairs can be arranged? Well, we can only arrange it like this. We can have 1, 2, 3, 4, and 5. So we'd have a 1 by 5. Or we can arrange it like this. 2, 3, and man, that just got really sloppy really fast. Those are the only ways that we can arrange. So my factors, or my length of the sides, can only be 1 and 5. Now let's head on to number 3. Use grids to find the possible arrays for each number. So we have that grid paper, and so I can have like this. We can have a 2 by 3. We can have a 1 by 6. So my factor lengths, because it's the same as if I just flip these and have it as a 3 by 2. So my factors would be 1, 2, 3, and 6. Now what about our next one, 16? Well, this one, even though it says use grids, since I don't have a grid to share, I'm going to know my factors, use my multiplication. So I know I can get 16 by 1 times 6. I know I can get 16 by 2 times 8. And I know I can get my factors of 4 by 4, 4 times 4. So these are all of my factors for my number 16. Okay, our next one says use grids to find the factors of each number. So very similar. So I have 45. Well, I know it's 1 and 45. I know it's 5 because it ends in that 5. So that's 5 and 9. And I also know I can arrange it as 3 and 15 because I know 15 plus 15 is 30 plus another 15 is what? Another 15 is 45. Now how about 30? Well, again, I know it can always be 1 and 30. I know it's an even number, so I know that's 2 times something, which is 2 times 15. I know 3 times 10 equals 30. And I also know counting by 5s, 5 times 6 equals 30. So those are my factors of 30. Now let's head off to number 7. It says use the grids to find all the possible arrays for each number. Use the arrays to write the factors. Well, 9, I could have 1 by 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'd have a 1 by 9. I could also have a 3 by 3. And I could also have a 9 by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So what are my factors? Well, my factors are 1, 3, and 9. Now, heading off to number 14. It's that same thing. How can I show 14? Well, I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's one way. I could have the same thing this way. Oops, I think that was too long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I can also have a 2 by 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. And I can have a 2 by 7 this way. So 14 and 1, a 2 by 7, and so what are my factors? We have 1 and 14, and then we have 2 and 7. Now let's head to number 9. Use grids to find the factors for each number. I don't have my grids, but I do know my multiplication well. 5 is only by 1 times 5. That's the only way. For number 8, I know it's 1 times 8, and since it's an even number, I know 2 times something, which is 2 times 4 equals 8. 23, that's going to be something that we call a prime number that we'll find out. The only way to arrange 23 is by 1 times 23. 1 row of 23, or 23 rows of 1. Now, number 10, 1 times 25. And I also know since it ends in a 5, I know I can multiply it by 5 as well. 5 times 5. So my factors are 1, 5, and 25. For 36, what do we have? Well, 36, we have 1 and 36. We also have 2 and 18. We have 3 and 12. And we have 4 and 9. So those are my factors. 1 times 36, 2 times 18, 3 times 12, and 4 times 9. 27, just like always, 1 times whatever that number is. And this one's nice because it's also similar to 25. We have, in that 20s, we have 3 times what? 3 times 9. So it's similar because it's close to it. So those are my factors for 27. Now let's head off to our next ones down here. So now we're on the next page, which are the more challenging word problems. So number 15 is asking us to use this grid to find two numbers that have 2 and 3 as factors. And if we get stuck, they give us this little hint here that says draw arrays with side lengths that have 2 or 3 as factors. So if nothing else, I'm going to start with that. So here's the side length of 2 that it's telling me to do. And I'm just going to make it a 2 by 2. And I'm going to think, is that also having 3 as a factor? No, because this only equals 2, and I can't do 3 times anything to equal 2. So let's add another one to it, and let's make it like this. So now it's a 2 by 2, which is a 4. So can I have anything that 3 times blank equals 4? Nope. So I go to my next one, and I'll fill this guy in. So now, instead of 4, it's equal to what? It's equal to 6. And can I have 3 times something equals 6? Yeah, 2. So here's one grid, one array that has 2 and 3 as its factors. So one of my answers is 6. Now, let's keep going this way. We're going to keep adding to see what we get. Well, this is 8. And you'll notice I only added 2 here. And since I'm at 6 and I add 2, I get 8. And 8 I can't divide by 3. Here, I'd add another 2. So what have I added so far? Well, so far, I've added 4 new ones, which isn't divisible by 3 because I have 10 total. So let's add another group, which means I've added 6 more. And hey, I would think since I've added 6 more, that it's also going to be divisible by 3 because 6, as we saw over here, is divisible by 3. So how many total do we have? We have 12 total right now. And is 12 divisible by 3? Can I have 3 times something equals 12? My answer is yes, it's 4. So 2 possible answers are 6 and 12. Now you may notice a pattern. I'm counting by multiples of 6. This is 6 times 1, 6 times 2. So without even having to draw an array, we could probably guess that 6 times 3 is also going to be 1. And if you guessed that, you are correct. So here's my group. And this is 18. And you'll notice 2 and 3 are both factors of that. I can have 2 times 9 equals 18. So I know 2 is a factor. And then I got 3 times 6 equals 18. So that 3 is a factor. So this one, any number that's a multiple of 6 is a factor. And we haven't even learned that word multiple yet. That's lesson 5, but you're on your way there now. Number 16. The dwarf planet Pluto takes about 90,403 days to orbit the sun. Write this number in expanded form and using number names. Well, expanded form means we break it down to its place value. So I have a 9 in the 10,000s, so I have 90 plus. Don't have anything in the thousands, so I can leave that one alone. But I have a 4 in the hundreds, so then that's plus 400. Plus, there's nothing in that tens place, so then I go to the ones, which is 3. So now it wants me to write it using number names, which is just a fancy word for saying write it using words. So what do I have? Well, I have 90,000. And then what's my next place value? 400. And what's my last place value? It's just this lonely 3. So I then have 3. Add it off to number 17 now. It says David makes $17 in an hour and he works 25 hours each week. Linda makes $25 an hour and works 17 hours each week. How much do David and Linda make together? What property multiplication does it represent? Well, first I have to figure out how much they each make individually, and then I can combine it since it wants it together. So I have 25 times 17, and you'll notice 25 times 17 will be the exact same thing as 17 times 25. So whichever one is easier for you, you can use. I'm going to use 25 times 17. So what do? Well, our very first step is we do 5 times 7 is 35. So I put the 5 down and I regroup that 3. Then I do 7 times 2 is 14, plus 3 is 17. And now I'm done with that. So I go to my next place value, which is in the tens place value. So I put a 0 down. So now I can start writing the tens. Notice, remember how it needs to line up. Tens place value starts in the tens. And then I have 1 times 5 is 5. And perhaps the easiest one left is 1 times 2 is 2. So now what do? I just add those partial products up. Regroup that 1. So one person would make $425. Now, since there's 2 of them, what do we know? Well, we know that David makes $425, and we also know that Linda makes $425. So that's 2 groups of $425. So I add those 2 together. They put both their money together, and you'll notice we get 850. So how much money do they make each week together? They make $850 each week. Now you might think, good, we're done. But make sure you go back and read the problem. We told how much money they make each week, but now I need to say what property this represents. And remember, we just talked about it. 25 times 17, that's the same as 17 times 25. So what math property says I can flip the order? Well, we have our associative, but that has to do with parentheses and grouping. We have our distributive, but that had to do with bringing a number from the outside to the inside with multiplication, break it up into its place value, and we didn't do that here. So this is my commutative property. So what property was it? It's my commutative property of multiplication, saying I can switch the order, still get the same answers. Now for number 18, what do you notice about the number of possible arrays and the number of factors in 22? Well, if you drew your arrays out, you would notice that you'd have an array of 1 and 22. You'd have an array that's 22 long and only 1 wide. You'd have an array that's 2 long and 11 wide. And you'd have an array that's 11 long and 2 wide. So looking at that, how many factors do you see? I see 1, 2. Well, these factors are the same right here, so I don't need to count them again. 3, 4. I see 4 factors. And how many arrays do I see? I see 4 arrays. So what do you notice about that? 4 arrays and 4 factors. Well, what I notice is that they are equivalent. They are the same. There are 4 possible arrays, and there's 4 factors for 22. Now heading off to number 19. Jane says 5 is a factor of every whole number that has a 5 in the ones place. Fred says 5 is a factor of every whole number that has a 0 in the one place. Who is correct? Well, let's just look at what they're saying right now. So I'm just going to make a simple place value chart. We have our hundreds, we have our tens, and we have our ones. So they're saying it doesn't matter what number's over here, as long as there is a 5, Jane is saying, then 5 is a factor. And what Fred is saying is no matter what these other numbers are in the hundreds or tens, as long as it's a 0 in the ones place, then 5 is a factor. So what do we notice? Well, if you've watched your video like you're supposed to or pay attention in class, we know our rules of divisibility, and they say if a number ends in 5 or 0, then 5 is a factor. So what do we do with this? Well, they are both correct. But now we need to do that explaining part. Numbers with, and I'm going to move my keyboard so I can write a little better, with a factor of 5 have a 0, oops, and that's an A, or a 5 in the ones place. Don't believe me? Well, let's count by 5, because every number we can count by 5 has 5 as a factor. 5, 10, 15, 20, 25, 30, 35. Notice they all end in a 5 or they all end in a 0. So now let's head to our last two problems. Which of the following are factors of 18? So remember, we're thinking what times what equals 18? Can I put a 1 in here? Yeah, 1 times 18 is a factor. So I'm going to check this off. What about my next one? What about a 2? Can I put 2 in? 2 times what? Well, if I look at my multiplication chart or know my facts, I know 2 times 9 is. So I can mark that 2 off. My next one is a 4. 4 times what equals 18? Well, nothing can. It goes from 16 to 20. It skips right over 18. So I'm going to leave 4 off. What if I have 6 in? 6 times what equals 18? Now you may think, oh, 6 isn't, but 6 times 3 is. So that's why you need to know our multiplication facts well. So I'm going to mark that. And this last one I think should be kind of obvious. What if it's 23? Well, it can't be because this 23 is bigger than the 18. And the smallest number we can put here is 1. And 1 times 23 is not 18. So we leave 23 off. So our answers are 1, 2, and 6. Now on for number 21. Which of the following are factors of 31? So it's that same thing. What times what equals 31? Well, 1 will always be a factor because I can always multiply it by that number. So let's check our next one. 3 times what equals 31? Well, 3 times 10 is 30. 3 times 11 is 33. It skips right over, so it's not this. What if I put a 7 in then? 7 times what? Well, 7, you'll notice, we have that same issue. It's going to skip right over. We have 7 times 4 is 28, and then it goes 7 times 5 is 35. Skips right over that as well. So mark that off. We see 31 was already a factor from 1 times 31. And what about 62? What times what equals 31 if we put 62 in? Nothing. 62 is actually a multiple that we'll figure out what that means later on in Unit 7. But 62 times nothing equals 31. That's a whole number. So these are our only factors for 31. It's what's called a prime number that we'll learn about in Lesson 7-4. Good job, you guys.